Well, good morning, boys and girls. Here's the next one of my little video clips for you. This time we're going to go and have a look at solutions and calculating concentrations. So if you remember from before the lockdown, we started looking at solutions. And just to recap very quickly, you have a certain amount of solute that we put into a solvent, and we end up with a solution where we have particles dissolved in our water. So our solute, we need to know the amount, which is usually in moles, and if you recall, we calculate the number of moles by the mass over the molar mass of the solute. Solvent is we need to know the volume, and the volume is in litres, and our concentration is the amount in a certain volume. So it's going to usually be the number of moles in a litre, moles per litre. Sometimes we can have grams per litre, but it's not a very useful unit for us to use, particularly when we're doing concentration calculations. Some of the other things that you need to be aware of is there is a term called a standard solution. A standard solution is a solution where you know the concentration. And so standard solution is the noun that we name it, so this is a standard solution, or standardizing a solution means that we are actively working out the concentration either by calculation, usually by volumetric analysis. So standardizing is to find out or calculate the concentration. Okay, so the other thing that I wanted to tell you about in the first lesson is going to be on what we call a primary standard solution. Primary means first, standard means known concentration. So a primary standard solution is a solution that we know the concentration of because we have made it up by dissolving the solute, a known amount of solute, into a known volume of solvent. So my primary standard solution is one that I make up because I have a known amount of solute and I add it to a known volume of solvent, and therefore I end up with a known concentration of solution. Primary standard solution. And when we get back into the lab, we will get you making up some primary standard solutions. So the concentration is the amount, usually in moles, divided by the volume in litres. Now when we're using a solid solute, the number of moles is going to be the mass over the relative molar mass. The volume we're going to measure with a measuring cylinder or a volumetric flask, and we'll tell you about those devices later on. So let's have a look at a possible calculation. So let's say that I dissolve 0.25 grams of sodium hydroxide into 250 millilitres of water. I'm told that the molar mass of the sodium hydroxide is 40 grams per mole. So to work out my concentration, I need to know the number of moles. I work out the number of moles because it's the mass over the relative molecular mass. The mass is 0.25 grams. The molar mass is 40, and so 0.25 over 40 is 0.0625. So that means my concentration, the number of moles, is 0.00625. When I do this calculation on my calculator, I'm going to leave all the numbers on the screen, and then I'm just going to divide it by 0.250 because we need to use litres, not millilitres. And when I push the equals button, I end up with 0.025 mole per litre. Don't forget the unit. Quite easy, therefore, to work out the concentration. We need to work out the number of moles using our molar mass formula. We put that into our concentration. Don't forget that the volume needs to be in litres, not millilitres. Very easy to do. You simply shift the decimal point 3 places or multiply it by 1,000, and there's our answer. Let's have a look at a second type of problem, and this time I want to make a 0.1 mole per litre solution of sodium carbonate in a 500 millilitre beaker or container. And I'm told again that the molecular mass of sodium carbonate is 106 grams per mole. If you're not given the molecular mass, then of course we'll need to calculate it by adding together the atomic masses. So I'd need 2 sodiums, 1 carbon and 3 oxygens, and you'll be given the data, or you can look it up in a periodic table. So this time the concentration is moles per litre. You should always start with writing your formula. This time I want to know the number of moles that I need to put in to my solution. The number of moles is going to be concentration times volume. The concentration I want is 0.1. The volume I want is 0.500 litres. And so the number of moles I want is going to be half of 0.1, so 0.05 mole. So the mass of sodium carbonate that I need is the number of moles times the molar mass. The number of moles that I need is 0.05. The molar mass is 106. When I multiply those together, I get 5.30 grams. So I'm going to have to dissolve 5.30 grams of my solid sodium carbonate in 500 millilitres of water to get a 0.1 mole per litre solution. This will be a primary standard. It'll be a standard because I know the concentration, and it's primary because I've made it up from scratch. So calculations for primary standards, very easy to do. You'll need to use a combination of your concentration equation. Concentration is moles per litre, and you'll need to use your mass and mole calculations for solid particles. Easy peasy, lemon squeezy.